Press it once to unmute.
Is this where we're presenting from, or are you guys just kind of hanging out in the chairs?
They're probably going to be like in this area. I don't know if I'm going to sit up here. Like probably after I do my part, I'm going to go sit in the chair.
Okay, cool.
Blake and Gerrae have.
Sitting with us, it's okay. It's up to you, but.
Sure.
And toss the catch box, you know.
Oh, I can be the catch box. Yeah. Okay. That's cool.
Yeah, we're gonna need it. We're gonna need it.
Okay.
So more participation with the catch box, the best. But it seems like everyone here is gonna knows what they're doing, so it'll be cool.
Yeah. A lot of good questions.
Let me
I'm not
turn
that
this.
athletic.
What's up, Adam? You want me to throw it from down here? Come on. Shatter the illusion that I'm an athlete. I can't. All right. Hello, everybody. Welcome to AWS Michigan Meetup. Thank you so much for having us. It's brought to you by Right Brain Networks and presented by Great Lakes Tech Leaders. So if you guys haven't joined GLTL yet, definitely check it out. Vibrant hub for fellow tech enthusiasts like yourselves. Really collaborate, meet folks, and work on projects together. I've got some more cards, passed one to my buddy Alex here earlier, so it'll be great to see you all there, participate in the live podcast every single week. And we've got the catch box here, and I hear that you guys are kind of experts at this thing, so you know how it works, but we've run into some issues in past meetups, so just for the sake of making sure we know how to use it, in order to talk to it, you put it right to your mouth, just like this, and that's how it's gonna be. So if there's any questions you guys have at any point during the presentation, just raise your hand and we'll toss the catch box right to you. It is very light, you're not gonna hurt anybody, I promise. So yeah, without any further ado, I'm gonna toss it over to Alex.
Thank you. Thank you, everybody, for spending some time with us today. We've got our rocket team here. I'm Alex Hamilton. I'm one of our directors of engineering. I have Gerrae Jackson and Blake Shaw here with me as well. Is there an echo, or is it just me? Okay. Okay. So we're excited to kind of share some of this journey we've partnered with AWS on. But first, I want to tell you a little bit about Rocket Mortgage and us as Rocket companies. So Rocket's mission is to help everyone home. And what does that really mean? That means meeting clients where they're at and helping clients through a variety of mediums and really helping them to achieve their dreams of home ownership. And so when we think about how is Rocket interacting with our clients and folks in the mortgage industry, on an annual basis, we have over 65 million voice interactions with clients. So if you think about how does that break down, that's over 147 million minutes of talk time. Well, we're on the phone with clients, we're helping to understand like where they're going through, we're helping them to put them in loan programs, those kinds of things. And as we focus on a lot of our self-service experiences, we really try to think about how do we invest in these novel experiences for clients that make their life easier. Some spaces that we've been very successful at creating these novel experiences are in our servicing space. So we have some AI and machine learning technologies there helping clients when they're calling us over the phone. And we're seeing right now about a 70% containment rate. And containment means we're able to help them without needing to directly talk with a person on the other end. And just to frame this specific project we were focused on is in our banking space, we see over 25,000 calls a month when people are in the beginning of their home ownership journey. So they're sitting there, they're trying to find their house, they're working with a realtor, and there might be times where they want to put an offer in. And maybe they're putting in offers on multiple houses, or they need to adjust different approval amounts, those kinds of things. But we're helping over 25,000 clients a month with those kinds of decisions. And so this is where Blake and Gerrae are really going to take us on this journey and how we partnered with AWS to bring this new voice AI capability to market in a very short amount of time. Rocket has a new ISM. ISMs are our company culture. It's called Launch and Learn. So it's really figuring out how do we eliminate these unknowns and how do we bring something to market as fast as possible. So I'm going to hand it over to Gerrae and Blake, and they're going to take us on the journey.
Thank you. All right. So hello, everyone. Hey. All right. So I got to get excited because we're about to go on a journey. All right. So imagine you're buying your dream home. What does that look like for y'all? On a lake, a lake house. Everybody else already owns their dream home, I'm assuming. How many bedrooms are in your dream home? Four. You got a 4-bedroom home. How many bathrooms? Large kitchen. What else?
Just big enough so that the kids have moved out.
Just big enough so the kids moved out. The kids can't come back.
There's no more room.
No pool, no yard. A 4-car garage. That's fancy. Yeah. Walk-in closets. A home bar. Nice. A speakeasy in your house. That's dope. Anything else? With a man cave. And she sheds. All of the above. She sheds, men caves. All right, so imagine you're in your dream home and you're touring your dream home and it's everything you've imagined. It has the 4 bedrooms, it has the 3 bathrooms, it has exactly what you've been looking for. And now you want to put in an offer. but the verified approval letter you have is not up to the cost of the home. So this house is priced at, let's say we are in Michigan, you can get all of that for probably, let's say, $425,000. I don't know, maybe 600,000 now, I don't know. So let's say this, 4-car garage. So let's say this house is $425,000, but your verified approval letter, you got it for $400,000, right? And your reason for getting it at $400,000 was because you were trying to stay in budget, you were trying to make sure your monthly payments was exactly what you wanted to be, but because it has that bar on the inside, you gonna go up the extra $25,000. You can do it. You can risk it because you have a place to drink now and drink away all your sorrows for those $25,000 that you spent over, okay? So we have built in the tool because let's say that day you're touring your house, you want to put in an offer same day to make sure that you do not lose your dream home. And you call your banker and they're not available. Oh my God, exactly. So what are you gonna do? You're in the bind, you're stuck, you can't lose your dream home. But luckily, you're a Rocket client. And this is what you do.
Not the architecture, that's not what you do. We'll get to that, don't worry.
There was a sound clip that should be played.
Where do they click it on the laptop?
There you go.
And play.
All right, on that phone call, the client is able to call our AI voice assistant, let them know how much they need their verified approval letter to be, and it gets updated automatically. It lands in their email so they can go ahead and put their offer in on the home. It is pretty echoey here when you're talking on the microphone, but they were able to put their offer in on the home from just calling the bot. No worries that your banker is unavailable. They could be on vacation. They could be out of office that day. They could be working with another client. But at Rocket, we care about every client every time. So we want to make sure that those little nuances of things that you still need to do to accomplish you getting your dream home, you're able to do that. And we have about, like Alex mentioned earlier, 25,000 times people try to get these VALs, verified approval letters, which are just a document to prove that you can afford the home. We have that happening like 25,000 times a month. And of those 25,000, people are calling in to ask to do these 90% of the time. And we want to make sure that all those people can get what they need right then and right now.
All right, I'm torn on whether I want to try to see if this catch box has a little less echo. You guys hear me? That seems a little better, maybe? I don't know. Is that better? Okay, great. Okay. I'll just use the catch box. I can manage. So, starting to look at the architecture, I really want to have, a conversation about this. I'm going to go through some of the elements of this, but I want to discuss it. I want to see what, some of our thoughts from the audience are. We have the AWS community right here, so I'm sure that we have lots of strong opinions about how we architect things and how we connect different pieces. So we start on the kind of the left side of this diagram. We have either a client or a TPO client, which is also a client, but a mortgage broker calling in, and that's hitting our Connect instance. With our Connect instance, the real reason for adding that piece is, just really so that it can have the telephony element, and that was an easy way for us to plug that in. We have Ed up in the audience here. He helped us plug in our specific number that's also connected to an Avaya system that we have outside of this, and we were able to get the right number for the client in that space. Once we go through Connect, we're then able to connect it right into Lex, and that's going to really provide us that speech to text and text back to speech on both sides of that. From Lex has natural connections to Lambda. There's a bunch of other drop-offs for other parts of this, but I'm going to kind of continue through the main flow on the top. Everything beneath is really about observability and recording and capturing all of this conversation along the way. So after Lex, we're hitting a Lambda that's a Python Lambda. And why a Python Lambda when we're a .NET shop? Well, we want to be able to interact with the LLM in an easy and transparent way. A lot of the tooling and technology and work around interacting with LLMs has been written in Python, and our local principal data scientist is a Python expert as well. So it made sense for that part to be in Python. But we are a .NET shop, so we actually had a lot of natural .NET expertise. So how do we break those two things up? Well, naturally, let's just add another Lambda that is a .NET Lambda that can, deal with those service connections, and then we can kind of split up our engineering efforts and, have the folks that are experts at the LLMs and the prompts and really dealing with that flow be in that Python Lambda, while we had the folks who are experts at connecting to all of our downstream services be in the .NET Lambda, and that allowed us to kind of like parallelize the efforts and work on those at the same time as well, just as long as there was like a clear, transparent contract between the two. Before I keep going, any thoughts, anything anyone wanted to, bring up, considerations, any immediate like, okay, hey, like, why didn't you do this? Or why did you do this? Ready?
Perfect. 1 for 1.
Is there anything downstream from the sort of bottom row here where you're going back to these logs and reporting on it?
Yes, there is. That's the next slide. I'll talk about it in a second. Good question, though. Anything else? Any other questions? Any other thoughts?
So are the responses pre-defined, or they are generative in the nature, and like the responses which are coming out from the text messages? So have we predefined them, or they are like free-form?
Great question. So this is always an interesting conversation, because really for this we were able to partner with a lot of different groups, and one of the groups that we particularly partnered with were conversational designers. Conversational designers are very used to, I'm going to explain every sort of word that's going to be in this conversation. Dealing with conversational generative AI, you don't, like, if you're doing that, then what is the point of the conversational generative AI, because you're just explaining every word along the way. And so we did have like a flow for like, this is what it might look like, but that's not always what it looked like. It was just like kind of, this is there's elements of it where, hey, like we need to say something very specific. And that's where, hey, like the prompts have to be, very specific for those elements. Like, this is what we have to say for this part. Like, hey, like the intro where we say a little bit of like a legal disclaimer, we have to say the same thing every time because it's a legal disclaimer. Like, if we didn't say that, we wouldn't be doing right by our clients, and we'd probably get in trouble. So there are parts that are like controlled and very much the same, and there are parts that are a little more freeform, where it's like, okay, hey, I just need to get these elements of data. I need to authenticate you, so I need to get like, the last 4 of your SSN and your phone number, or different pieces like that. And that can be a little more freeform, where, hey, like the prompts are more like, okay, hey, like I just need to get these elements, and this is the form that they need to be in, and you need to keep going until you're able to get these. We can't go through until you do these, and then we go and we check these against what exists as well. And interestingly enough, too, that's for the generative AI side, it's not only the, okay, hey, the things that I'm like saying to the client, but also interacting with those downstream services. So like the generative AI itself is like, okay, hey, you're going to get something back from this other Lambda. Deal with it accordingly. Like, hey, like this is the information that you're going to get back. This is what the response is going to look like. So deal with that, figure out what other things you need to get, and go and get them accordingly, so then you can actually complete the task at hand. Does that answer your question?
So I see here it looks like really this shows like the path when somebody's asking something like, hey, I need an adjustment to my mortgage. But what if somebody asks something, say, silly or like off the wall or something that has nothing to do with, you know, the task at hand that's going to the your back-end services?
Right. This is the scariest part of like the whole. Yeah, so that's a great question. Like dealing with divergences, like when someone wants to not talk about something or they want it. So that was like probably half the engineering work was to just make sure that, hey, like if someone got sidetracked, that we brought them back to the conversation and that the LLM didn't decide to just go on a tangent with them and go on that side journey. So with like a very specific focus like this, it wasn't super challenging because it's like, okay, you have a very clear, like this is the one thing that you do. You need to help the client update their val. They need to give us a small handful of things to let us know who they are and the number that they want to update it to. And we can, as long as if they're doing anything else, we're going to say, that's not part of my job. I'm going to bring you back to this and let's take care of that. I think that will be an increasing problem that we want to identify, and that's something that we really are looking to keep in mind as we grow this, because as there are more things that we make the agents capable of, we want to make that there is that balance that, hey, now you can do a lot of things and the client expects it to do a lot of things, that we meet their expectations and that we're still aligning with, okay, like here's something that is supportive for you and helps you through the process and helps you all along the way. So, yeah. Got a question back there? Oh man, you're gonna test me now. You ready?
All right, you made it. Can you hear me? Yeah. So you mentioned about the disclaimer up front, you know, to let your clients tell what this is like a legal thing and do right for the customers. What are the other considerations you had for being responsible, right? Like, did you consider different accents, people talking in different accents and stuff like that?
Thank you. That was my question.
I'm gonna blame the lights on that one miss earlier. Yeah, absolutely. I mean, so this is something that, like, hey, you know, all along the testing, at this point, you know, this is something that was early. We did a lot of manual testing. We tested in all different ways. Hey, give this number out to like whoever. Like, let's have them go through it. Let's go through the whole process. And I'm gonna hop to the next part in this to talk a little bit about like how we were able to achieve that. This doesn't show a bunch of other extra stuff, but really that first diagram and this diagram are actually a combination of two solution architectures already presented by AWS. The first one specifically around, interestingly enough, I think that the article was called Bedrock Agents, which was funny because it actually isn't agents for Bedrock. We'll talk about that a little bit later, but it was really kind of like the precursors to that, where you have total control over it. This second part really was our ability to deal with getting the full conversation and being able to understand like what was happening during the conversation, have both the audio and the transcripts, so we could kind of evaluate every step along the way and also see, okay, hey, like, well, what was the LLM thinking while it was going through the process, and you know what actual text did we get when we transcribed the audio? What was the entire conversation that happened? What were some of the gaps and what was the timing all along the way? Interestingly enough, Connect does have some natural functionality to be able to do a lot of this, but only if there's a live agent. So no live agent here, so we had to, you know, use some workarounds, but at the same time there's a lot of the event-driven functionality and streaming functionality between Kinesis here and Dynamo to kind of capture like all of the metadata and kind of tie all of those pieces together, bring all of the little snippets of the recording along the way and create a full conversation. And I lied, I said 2 AWS architectures, there's actually a third that we just kind of peek into a little bit, and this copy into the last audio bucket, we actually go then to leverage a post-call analytics architecture where we take these same audio files and then do sentiment analysis on them, and use some LLMs to do a summary of the actual conversations as well. With these like similar conversations, a lot of the summaries look the same, like a client went to update their LTV. So as you would expect, but at the same time too, that allows us to kind of continue to practice that analysis of conversations and then expand that to other conversations that aren't just with the LLM. So speaking back to how did we test this with all those different things? Well, this gave us the observability to be able to do that. That, hey, like we could have all those conversations, we could start to look at those, we had all of the data in aggregate too, we could start to ask questions of the data like as a whole, see how the conversations were going, see how long they were going, see the short, see like where there were the gaps, see like what the response time was all along the way. A response time end to end. So what did it start with, or what did it end with? That's a good question, right? So as you're starting to like work with these, the initial focus is a lot on accuracy. Like, I want to make this right. I can make this right, and then I can make this fast. And to make it fast, I then want to kind of balance between, okay, like how much am I paying to make this faster? So with that said, I think that when we initially started, response times were like 10 seconds. It's something terrible. You would never want to wait 10 seconds for a voice interaction. But it was saying the right things, so we knew we were on the right track. So you figure out, hey, like what are the things that I can do to accelerate this? Well, that's where a little bit of prompt engineering comes in, and okay, hey, let's see what we have to do to make the LLMs like smarter, and then at the same time, or know the right things to do and do less processing and do more what we need them to do. At the same time, too, if you look at the services, some of our services were taking a while. So that's where, hey, like when you have voice interactions, there's very low tolerance for latency. So we have to make sure that every service that we're hitting downstream is responding as quickly as possible, that it's not having to like go in and do some crazy SQL join or hit 10 other downstream services. That needs to be fast, and so we have to have that visibility all along the way, the full trace, so that, okay, we can say, okay, hey, it's taking 5 seconds for that downstream call needs to be milliseconds. That's not going to work. Or, hey, like for eventually, in like the most recent iterations of this, we're even doing things like sending an email to the client like with their actual val, and all of those require like different connections to things. Well, realize, hey, some of those things you can do async and just say, hey, like, we're going to take care of this, just, it's coming your way. And some of those things you want, like even the synchronous response for, and you got to just make those calls happen quickly and remove any bit of latency that you can along the way. And so with all of those adjustments, we are able to lower the latency down to, always under 5 seconds, and oftentimes probably like an average of like 2 seconds, which, still for voice interactions, there's room for improvements though, but I think that even on top of that, even just updating the models, because I think we started something with like Haiku Instant, and we migrated, no, not Haiku Instant, sorry, Claude Instant, and we migrated to Haiku. Even just that update took seconds off the latency, which is amazing where, hey, like I have to make very little change, and all of the sudden, I have these increases, I have this performance increases, I have better responses, I have better latency, and that's a lot of times the power of having LLM of choice. Does that answer your question? Okay. Any other questions out there?
What is Amazon getting? 5.3.
5.3.
EHI 3.
That's a good question for Amazon. All right, we can keep going.
I'm gonna try it again.
Okay, go for it.
Hello. I pressed it. It's green. But you guys can't hear me though. Unfortunately, I'll do the mic. Okay, there we are. I was going to say, because I'm not throwing I'm not working out today at this event, so I wouldn't be throwing the thing. Okay, so I want to talk a little bit about our journey. Blake and I are going to spend the next few slides kind of going over the experience that we had while developing this AI voice assistant. Could you turn down the echoing, please, if that's possible? And hopefully at some point we'll be able to play the video so you'll be able to hear what the assistant sounds like. But this was our first experience with voice AI. We did a few other things in the Amazon space with AI, and we hadn't quite explored this, but they were like, oh, you've worked with calls before, you can do an AI voice assistant, and that's kind of how we got looped into this project. And with that said, one of our other isms is we'll figure it out. So we didn't know a lot going into this, but we all worked together to try to put this together, and it was great. So I'm gonna first talk about our cross collaboration. So it's only 2 of us here, but there was lots of people involved in making this situation happen for us. It started with product that had this idea last year, and they presented it to our senior leaders, and they then had a data science group come together and do a quick POC. So those data scientists did something extraordinary. It was just the beginning of the project, and we got a glimpse of what it would look like for us to have a voice assistant. Those data intelligence or data science engineers didn't really have the skill set to move this to production. So that's how we got kind of involved. So the engineering teams got looped in, and it wasn't just our engineering team that worked on our C# Lambda, but it was also the engineering teams that were business area specific. So we had the TPO team that handles our brokers, and then we also had our RMO team that handled our origination endpoint that would update the val itself, and everybody all worked together. We also had our wonderful engineering team that works on our telephony area. So we had lots of engineers kind of working towards the same goal, and once we had everybody that we needed in the room, we were able to identify the other pieces. So InfoSec, information security team, was heavily involved as well. This is a new tool that we haven't quite discovered, and we haven't really explored it fully as a population about how to communicate with voice AI and what that really means for like security. We're dealing with client level activity here, where we are updating a document on a client's loan, which could, cause some security concerns. So we had InfoSec involved heavily in this as well. Lots of people from our observability team to help us create our dashboards, so we can see everything that was going on, all the calls that were coming in, so that we can, they worked together with InfoSec to identify any, if we were having random bots dialing our number, to prevent any of that stuff. And then the last piece, Blake kind of touched on it a little bit earlier about our conversational designers. So the rest of these are kind of outside of product in a technical role, but we did also have a non-technical participation in this as well. And our conversational designers helped us better write our prompts so that our voice assistant was talking in the way that we want to talk. So not just saying what we want to say, but saying it in a way that Rocket says it. So adjusting the tone, we want to speak to our clients with empathy. We don't want our bot to be talking crazy, basically, to anybody or whatever, or do something crazy. So it was one time we were testing out, and I was yelling at the bot. I said, "Oh my God!" Like I did something like that, and it was like, "I'm so sorry that you're frustrated right now," So we wanted to make sure that we had good conversational designers that could write the prompt, not to say verbatim, "I'm sorry that you're frustrated," but to build this persona about our AI voice bot that would allow it to give it the Rocket feel. All right, the next thing I want to kind of talk about, these are just high-level things that we wanted to address on our journey, is that our speed to market, we like to move fast. We work Quicken Loans because we move really fast here. And one of the ways that we were able to rapidly prototype this is just to break it into a small problem. So the verified approval letter update is a very small chunk. It's just one thing that needs to get done. It's something simple, updating a verified approval letter, hitting an endpoint to do that. So we were able to iterate quickly because we only had that one thing to solve, so we weren't having to think about the problem too hard, and we can use that energy and time to focus on the technology itself and build that and do it right, like Blake spoke about earlier. And then we can always add more problems to that once we got our foundation together. So we were able to launch and learn. That means doing something quickly, getting it out there, breaking it into smaller pieces. So one way that we did this, and we're able to kind of like test it out, and hopefully my video plays, y'all. Hopefully it plays. All right, there's no sound to this one, but this is a video just demonstrating how we were able to test out in the Lex tool, the bot that allows you to do the same thing as the voice. All right, so someone says hello, and it says, hi there, what's the client's loan number? The user gives the loan number and hits enter. Following that, this letter is for Sunny Graves, right? Yep. All right, and then they're gonna, great, currently Sunny Graves has an approval letter for $200,000. What would you like for the new amount to be? The user says $210K. And the voice assistant says, let's confirm you're looking to adjust your purchase amount to 210 for Sunny Graves. You say yes, and then it's done, right? So that's how the conversation would flow if we heard the video. What's beautiful about this LexBot tool is that it's omni-channel. So the same way you would type in is the same system that you would talk to. So you can type or you can call. So we could reuse the same code in a way that if we needed to use it in our chat bot, you can use it the same way. So that's pretty cool. A couple things I want to highlight on this slide as well is that you guys noticed the K. Someone said 210K. All right, so some of the ways that we were testing these things out is like trying to think of the many ways people can say things and make sure that the LLM understood that those are synonymous. So we would try 25 grand or try things like correct versus right versus yeah versus all of that. In the same way, decrease, reduce, or lower. But people talk differently. Not only are there accents, there's dialects. So people might say nah, I say nah instead of no a lot. So we want to make sure that those same instances are responded to in the same manner, and the LLM was very diverse in its understanding. In addition to that, Amazon Polly has a tool that you can go into the console and you can view the different voices. They had like maybe I don't know, I'm making this up, 15 voices maybe you can choose from. There were some male voices, some female voices, and then you're able to test those out and hear what they sound like. So in order to make our voice more personable, we had to use these SSML tags. So you saw in the video, there was one called speak. With that tag, that's when it's talking out loud. So a couple of other ones that we had to use commonly are break, which would give it a little break. And then we also had say as and then currency. So instead of it saying 1,000,000,000, it would say $1 million, right? And we had to do the say as a bunch of times because we have loan numbers. So they were saying 9,120,000, right, exactly. But we need them to say loan number 9933, whatever the loan number may be. So those are some of the ways we could like test those small tweaks using the console instead of having to keep calling the bot and talking to the bot back and forth. So that was pretty cool. All right, so I'm handing over to Blake.
All right. This seems to be working better now. Perfect. Now you have to throw that if they have any questions. Talk security, right? So security was definitely like one of our priorities. Like, anytime you're working with AI, anytime we're working with clients, anytime we're doing anything really, like, security is top of mind. And so we took, a multi-pronged approach to that. Let's have a defense in depth strategy. Let's identify all the ways. Anytime that you're putting something out there, there's going to be vulnerabilities. There's going to be trade-offs. You're going to make decisions around like, okay, hey, like what is the level of security that I need to apply to this workload? And so to be able to be successful with that, we really partnered with the experts in the space. And so that was our own InfoSec architects. We partnered with a couple of them to get a lot of like great feedback on the space, and also, you know, help grow their experience too, because the models that we were defining for these like voice interactions would continue to the future for other voice interactions that we'll continue to have across like Rocket. And we were able to work with an AWS security architect as well, and that information was incredibly helpful. Even just, hey, like starting off from, okay, hey, these are all the things that you could possibly do to secure your voice workload. Some of the things that we explored along the way, because voice workload is a little different. You know, you think about your digital experiences. A lot of like the security for that is, I won't say solved, but like is pretty commoditized. You know, you have your logins, you have, you know, your biometrics, you have even like passkeys. A lot of those things are fairly straightforward, but in the voice world, you're not saying passwords, you're not doing all of those exact same things, but there are some parallels, right? So there's biometric options there, and so we explored some of those. We explored voice biometrics, being able to do voice match, and you know, identified, hey, like what some of the interesting legal struggles there that you might need to encounter with now capturing voice data and using it for biometrics. With this, one of the big security points that I think we identified is if we have good observability, we can see like what's going on along the way. So if there is bad actors, we had the visibility into those immediately. We have, you know, hey, like how many people are calling this? What is the content like of those calls? What are folks trying to do? What are happening on the other side? Are they like actually client? The visibility piece was super helpful and super key. One of the other elements to it is obviously, hey, like again, that trade-off. So recognizing what was our responsibility in this space. What is like the worst thing that could happen if a bad actor got in here? And so if a bad actor got in here and updated your val, and then you got sent an email, that's not going to affect your credit. That's not going to result in identity theft. That there's relatively low risk, and that was, you know, part of the reason why, you know, we chose this use case, so then we could build security that matched that, and we could really focus on the generative AI elements. I think that kind of captures a lot of like what we did for security, but we can talk about it some more if anyone has any interest, any questions before we keep going. You want to catch box it? It's go, Gerrae, go. You can also just pass it.
Is there an opportunity for someone to say something that would somehow downstream turn into a really bizarre SQL statement?
Yeah, I think that's a great question. Yeah, the equivalent of a cross-site scripting, or, you know, bad inputs to be able to cause trouble downstream, and that's where, hey, like, you know, interestingly enough, the fact that there wasn't like a direct connect to the services, that there is that like LLM in the middle. The LLM in the middle really had, you know, very strict things that it could say to those downstream services. There wasn't like a lot of like, I mean, obviously for any of those downstream services, you want to be able to, hey, like apply that same security, make sure that they can't take a SQL statement and do that. But you have even that one level on top of that, because essentially you have a person in the middle who is, I'm calling it a person, but like you have essentially processing that's happening in the middle, so it's not directly interacting with the downstream services. Now, with that, there's also the concerns of, okay, hey, like, what are some of the bad inputs that might make the LLM provide hallucinations or go in other different directions, be able to, you know, jailbreak the LLM. And I think with that, again, like kind of the narrow use case and very specific prompts allowed it so that, hey, like there's only like very specific things that, hey, like we would take as inputs, but at the same time have, you know, some of the flexibility that we mentioned before, that, hey, like we're looking for something very specific, and as long as we can translate it to that very specific input that we're going for, we can continue moving forward with there, but we're only going to allow that very specific kind of input.
You ever make it talk to itself?
Oh, how we made this one specifically talk to itself. I don't know, not that I know of. Maybe. Actually, I think we did accidentally one time where we were testing like on a call and someone was testing and then the other person was also testing on the call and they both had their mics unmuted. But I'm pretty sure it just said, I'm sorry, I can't help with that. So not as exciting as an outcome as one might expect, but definitely an opportunity for us to make an agent that would just try to go through the process to connect with the agent doing the process. That could be fun. Automated testing, so yeah.
All right, so these last couple slides are going to go through some lessons learned that we had over time, some good things and some things that had opportunity as well. So I'm going to talk to our system integration. So we alluded to it a little bit earlier, but when we created this voice AI assistant, it was through the AWS stack, and we already had an additional stack already set up for our post-call analytics. So it was very easy just to tie those two threads together. So once we had a call, we could send it through the post-call analytics tool, get a transcript for that call, get a summary of that call, get the sentiment of that call. So it was easy to see how our clients are reacting to the AI voice assistant. When I said, oh my God, I can't believe there's another robot on the line, it caught that as this client is frustrated, and it marked that with a low sentiment score. So we could see easily in an aggregate way how people are responding to that AI voice assistant and be able to make some adjustments there. We could also see if the AI voice assistant was saying things that it shouldn't say or saying things in a weird way in response. And then we could see what our clients are asking of the AI voice assistant. So maybe that would lead towards some adjustments on our end that way. And then the other one I want to speak about is our leadership support. So y'all seen on the other slide, we had lots of people in the room to help get this involved. We also had our AWS team come in and help us for an on-site for a few days. So the leadership support that we had to do this and really rapidly prototype this AWS AI voice agent was tremendous, so much so where the investment was really put into it, and you can tell when you put the investment into a resource, then it'll come to life.
Nice, thanks, Gerrae. If we look at some of the other wins, if we look back at the architecture, everything was serverless, so things scale vertically nicely. So as we expand this from like a small pilot group of 5 clients, 10 clients, 100 clients, 2.5 million clients, everything should scale naturally. Fun fact with that folks should keep in mind as we continue to scale. A lot of the things that you might have to adjust are actually just the quotas. So, and you can do a lot of that yourself. So that's a good problem. Hey, like a problem that all I have to do is just ask someone to change a number. That's the easiest change I have to make. I don't need to change my code. I don't need to adjust anything else. So that's a good vertical scaling problem. From a learning perspective, as you're going to this, we did like a little immersion with AWS over the course of a handful of days, and it's like, okay, hey, we want to get this conversational AI out there at the end of this, and we want to provide value, and so hey, everybody has to do their things. Everything has to be going towards the mission. But at the same time too, there was really a good chance to do some learning along the way and take some detours. So the architecture we had, you have a lot of control. The Lambda essentially is making all the calls. You're controlling all the prompts back and forth from the LLM, but you're also doing a lot of maybe undifferentiated heavy lifting there, just the code that you have to interact with that, maybe to deal with the prompts, maybe to deal with keeping the conversation and the history of that. All of those are, that's not the magic that you're providing. That's just the extra work you have to do to make that work. And so that's where we got the chance to play with agents for Bedrock, which is a layer of abstraction on top of that, where hey, a lot of those things are managed, a lot of those things are controlled. It uses React reasoning to dive a little deeper into some of the questions. There's the opportunity to define hey, pre-orchestration prompts, orchestration prompts, post-orchestration prompts, specific calls to knowledge bases, specific calls to action groups, where hey, all I needed to do is hey, maybe I don't even need to create this other service Lambda. All that I needed to do is just define an open API spec, and I've got at tons of open API specs that, hey, all of a sudden I have my ability to scale and I no longer need to, hey, every time I add a new capability, add a new service to my Lambda, I just add the open API spec that I already have, and that takes me 5 minutes, and all of a sudden my Lambda knows how to do something else because there's good definitions around that open API spec that exists. So good learning there and good notes for the future. Now let's talk about some opportunities that we had. So a lot of times, we talk about like horizontal scaling and vertical scaling. We're talking about like making this compute layer like stronger, or like scaling out to like a bunch of different tasks. When I'm talking about horizontal scaling here, I'm really referring to the kind of problem that I just talked about right now, like being able to add more capabilities. So as we saw it now, if I tried to scale that, every time I tried to scale that, every time I had to add something new, I had to like go and code here, and I had to go and code here, and I had to go and code here, and that doesn't scale horizontally. Every time I want to add a new capability, I want to be able to do the minimum amount of work possible to make it so that my client can do more. And we identified that as an opportunity, and clearly we're kind of looking into how do we solve that? How do we minimize the work to provide more value? From an observability perspective, this was an interesting one, and I've kind of put this as what didn't go that great because of all the work that we had to do to provide the observability. So really, again, like, hey, like as I add anything, I want that observability to be like built in. I don't want to have to, every time I add a new thing, go and add all of these other elements on top of that to have that observability. And again, I think that, Agents for Bedrock and a handful of other tools definitely speak to, okay, how can I have some of these things built in and already part of the process and easier for me to recognize and leverage.
All right, hopefully the voice recordings work just fine on this one. And if they do, then we can go back and listen to the demo. But I wanted to speak about voice in general as something that I wrote what did not go well. I usually like to say it better than that, like what are our opportunities, to make it sound a little lighter. Because it did not go well, it just wasn't the best experience. So there's levels to the voice. And there's also levels to the cost of the voice. And then again, our Rocket brand is so strong that we want to make sure that the voice that you're speaking to is a good voice, right? So we would like to have a custom voice. We actually had the opportunity while we were in our 3-day to hear the Colonel represent the voice of KFC. And, I can't do it. I'm not good at impressions, but he did a great job. And if you called KFC, you talked to the Colonel. Like, isn't that a great experience? And when we call Rocket, we want to make sure we're speaking to somebody that, you feel like you're talking to a person and not like talk to a robot per se. So there's levels to these sound clips. And, you actually want them to say things in the way you want to say. I know the question was brought up about accents earlier and all of that. I have to hear my Bose speaker say, you're now connected to Gerrae's iPhone. Oh, no. And my name's Gerrae. So I have to hear it say Gerrae a million times. I hate it. But Amazon Polly definitely calls me Gerrae. So thank God they can phonetically pronounce my name. So I'm going to play a couple of sound clips so you can hear the difference in the tone here. And they're all saying the same sentence. And it's a lot of sentences. It's the same sentence that has S a bunch of times, so you're hearing this, which is kind of difficult for them to say, and a lot of alliteration. So hopefully play the first one. This level is called Neuro. This is the bottom level.
Let me try to play it on my phone. I pulled up
the slide.
Let me go on to present.
Yesterday, in New York, I saw Sheila selling seashells by the seashore during a stunning sunset.
All right, so that was the neural version. Here's the long form.
Yesterday, in New York, I saw Sheila selling seashells by the seashore during a stunning sunset.
Okay, you already see the difference there. And this is the better version. Now, this one is generative.
Yesterday, in New York, I saw Sheila selling seashells by the seashore during a stunning sunset.
All right, so it gives a little bit more emotion to the talking. She's not talking like a robot. She said a stunning sunset, you know. All right, so we want to, you know, eventually get to the point where our voice is more conversational, right? And you feel like you're talking and you can have a natural conversation like you would with one of your friends or your banker, essentially. All right, and then the other piece I want to speak about is the pilot audience. So we did roll out this small problem to a group of people, a small group of people, but because our pilot audience was so small, we didn't get the amount of traffic that we would like to see to make any data-driven decisions, right? So if you're only getting so many hits on it, you can't find trends, you can't find you know, the information you need to be able to make decisions and move forward. So before thinking about any problems, we want to make sure that when we roll it out, it reaches an audience where we can make those quick pivots and move forward based off of real raw data.
All right, I think that's all we got. Yeah, I did my vote.
Sorry.
You want to do the
Yes, we can do the demo now off of Blake's phone. Technologist right there. Technologist of the year. Clap it up for Blake. That was a weak clap, but we're going to keep going. All right, here's the demo.
Hi, thanks for calling Rocket Mortgage. Just so you know, our calls are recorded and AI powered. I can change the amount shown on your verified approval letter. What would you like to change it to?
$300,000.
Please say or enter the last 4 digits of your social security number.
5462.
That was 5462, right?
Yes.
While I process your request, you may experience silence. To confirm, you want to update the purchase amount on your verified approval letter to $300,000, right?
Correct.
Good news. The approval letter has been successfully updated. Your document will be sent to your registered email in next few minutes. If you need to make future adjustments, I'm here to help. Thanks for using Rocket Mortgage. Have a great day.
All right, so that was the demo. You did see the silence, and she made a little blurb about the fact that she'd be silent, but that's the processing time that's happened behind the scenes. Those are some of the things that we were looking into to improve the latency. It was way worse, but it's getting better over time.
Yeah. So you talk about the last part? Yeah. Definitely, that's an opportunity there to hey, kind of play with some of, and that's where some of the, if you look back at the architecture, some of the tools we're using along the way, like Lex, like there's no opportunity to say something without getting a response back. So like you're limited by it. I can only say things until you say something back, and then I can say something there, and that's where maybe we'll adjust elements of that so that we can have a little more control. But yeah, even that, like the last part, the big piece that was taking a long time was going to try to send an email, and that kind of speaks back to like any processing piece that you have to have along the way that may take longer. You're gonna have to speed up those things, and I think as we continue to go and explore this space, we're gonna have to find better ways to be able to deal with some of those asynchronous tasks and to keep the conversation going while asynchronous tasks are happening, and maybe just update you somewhere along the way later. Definitely something that we're definitely engaged in. Yeah, the keyboard sounds. Yep. All right, I think that's all we got. Thanks so much. Questions? Online questions? All right.
Okay, I'll speak really loud and hope that works. So, John Carter on Discord
Yeah, I think that's always a good question. I don't think at this point we have, tons of people trying to like call and update their valves all at the same time, just because of like the nature of like that process. Like, hey, like people will be, updating their valves periodically. But in general, that's a challenge that I think like architecturally we always have to consider. I was like, okay, hey, like, do I want to deal with this as like, a Lambda workload, or do I want to deal with this as like, a containerized workload? And I think there's going to be trade-offs there all along the way. One of the things to obviously consider is the execution of each element, so that, hey, like even if you have continuous workload, like there's not necessarily like you can have lambdas have like continuous stable workload just because of their ability to like scale out too. Like the ability to scale up to tens of thousands of lambdas, and it's amazing when you look at, hey, like the quota limits on like an account initially might be like 1,000 or like 2,000, but the like, hey, like set limit on like what they can go up to like eventually, I don't know what it is. We've updated some of the quotas in some of our accounts to, again, like tens of thousands of lambdas that are running concurrently depending upon like the use case, and it's handled it brilliantly. So I think there's going to be trade-offs all along the way, and what it really comes down to is kind of balancing those trade-offs and doing the right trade-off analysis for the problem.
How long did it take for you to go from idea to production?
Ooh, idea to production. I mean, I don't know if the idea came out before the immersion, but the first time that I heard of it was pretty much like the day before the immersion. We went through the immersion, and that was what, like 2 days, and by the end of it, we, I think, had something that was like ready to test and out there. We ran through it and played with it, I think maybe for a week just to make sure everything felt good, and then it was out there. So I don't know, 10 days, 7 days.
So Rocket is clearly an early adopter. We see a lot of customers kind of still in exploration. What is the biggest piece of advice you would have for those organizations who quickly move these generative AI workloads to production?
Yeah, I think that, like match the level of abstraction that matches like your use case and your skill set. AWS provides like so many different levels of abstraction to meet you where you're at, and then a lot of capabilities within each of those levels of abstraction. So find a use case that matches find a level of abstraction that like matches your skill set, and then find a use case that is viable through that level of abstraction, and just do it. Get it out there, start playing around with it, start to see like what's working, not working, test all of the elements of it, utilize all of the responsible AI elements that exist between the AI framework or guardrails, and start exploring. Absolutely. Yeah, so the LLMs that we used the foundational model LLMs. We did not add additional training. There's no fine tuning on top of them. We just used them as is and just modified the prompts accordingly. Yeah. Which does bring up a valid point that, hey, like sometimes these LLMs are evolving too along the way, and so there has to be kind of continuous observation that, like, hey, like one of the things we're doing is we're constantly kind of checking to make sure that, okay, hey, like the responses we're getting back are still consistent with what we're expecting. And we had at one point where, hey, like the responses we're getting back started to change from what we were expecting because the underlying models had changed and evolved, and so we had to update our prompts accordingly to align with that. So it is a bit of a moving beast, and hey, like that's where, hey, like it goes both ways. So suddenly you'll all of a sudden get improvements that you don't expect, or suddenly things will start acting a little bit differently than you expect. And that's where, hey, like you need that kind of continuous observation and continuous checking, and that kind of also feeds back to like, okay, hey, like you're gonna be getting non-deterministic responses, so you need to be tying that back to reference against this ground truth.
Since it's an audio call, your context must be very long, right? So are you able to get back
Yeah, so something that kind of makes that context a little smaller is turning it to text, right? Like, so if you transcribe everything, then your context is just text, and you can kind of maintain that for a long time. Unfortunately, you do lose tone, right? Like, you don't have that like same contextual tone along the way. But again, for a small use case like this, like tone isn't as critical for every element, but it's definitely something to consider. Like, how do you maintain that context, and how do you make that a part of this with the increase of like context windows? Like, I mean, like Haiku and Sonnet and Opus all have context windows of 200,000 tokens. Like, that's a lot. That's a good bit that like you can maintain in that context, like for the prompts. But also on top of that, being able to take the context that exists already and run that through an LLM and summarize it, make this a smaller context, so then that way, hey, like you can kind of use the LLMs to create this like virtuous cycle of, hey, like dealing with summarizing and keeping me up to date with where we're at. Mm-hmm. Any other questions out there?
So, do you use AI to analyze the effects of previous calls to the point where it could give you advice that says, well, people seem to understand this prompt better if you say the word and not also, or, you know, something like that?
I think that's a great opportunity, and I think that's something that we're continuing to explore. Now that we have a lot of this data and transcripts data for other calls available as well, being able to, hey, take all of those transcripts or even the direct audio and provide those as context to be able to ask questions exactly like that. I think that's definitely something we're continuing to explore, and that's a good opportunity that we've identified.
Have we considered using something like this for coaching team members? Training up?
Sure, why not? Yeah. It's definitely been brought up as an idea, and I think that kind of goes back to like some of the notion for some of these is falling in love with the problem. Like, hey, like let's figure out like what the problem. There's so many different problems that we can solve with generative AI. So let's go back to the problem. Let's identify, hey, like the data set that we have. Let's find the problems that are the most important problems, and use the AI to kind of be the solution that bridges that gap between the data and the problem.
All right. Thank you.
Thanks, folks.